Hello students. So here in this video I will explain the methodology of one-step growth curve for the bacteriophage and the calculation of that. So I hope this will be helpful for you. After the completion of this video, if you have any doubt, you can contact me anytime. So here in this practical, name itself indicates that it is a one-step growth curve, right? So here we need two things. First thing is the host suspension. Here our host is E. coli and we need a lysate. So we already had a lysate and you people know that how to prepare this lysate, that chloroform treatment and all. But for this practical one-step growth curve, one thing is very important, and that thing is the number of cells of E. coli and number of viral particle in the beginning of the experiment. So here we will take 2 into 10 raised to 8, this much number of E. coli cell, and 4 into 10 raised to 6 lysate, right? So this is very important because this number gives us the multiplicity ratio. Means in the beginning of the practical, we are aware that we have this much number of E. coli cell and we mix this much number of E. coli cell with this much number of virion particle, right? So how to begin with this practical? So first step, you have to prepare the exact two solutions, no, two suspension. One is for the E. coli, one is for the lysate. After that, you have to select one tube, and in that tube, what you have to do is, so in that tube, you have to write down the AT. AT means the adsorption tube, right? And in the adsorption tube, you have to add 0.9 ml of your E. coli host suspension and 0.1 ml of lysate. So exactly total volume 1 ml you have to add. After mixing these two, you have to count the time. So now you have to wait for 10 minutes exactly. It's the absorption time when your virus particle will exactly adsorb on the surface of E. coli cell, right? So this 10 minutes is very crucial. Remember that every time you have to maintain the temperature 37 degrees Celsius. Okay. So after 10 minutes, you have to transfer zero point 0.1 ml of this into one tube. So during these 10 minutes, you have to prepare more tubes, tube 1 and tube 2, in which you need 9.9 ml of phage broth, right? That's a tea broth. And you have to label 10 raised to minus 2, and another tube you have to add 10 raised to minus 4, right? So in the tube 1, what you have to do is you have to add 0.1 ml of this from adsorption tube, 0.1 ml, add into this. So it's a 100 time dilution, and that is why it is 10 raised to minus 2. Same thing, 0.1 ml, you have to add into next tube, so that is the 10,000 of original one. So we have to take this as a 10 raised to minus 2 and 10 raised to minus 4. So now what you have to do is, after the dilution, after the mixing, you have to calculate exactly 20 minutes. And after that 20 minutes, so you have to collect 0.1 ml from any of the tube. Suppose I'll select 10 to minus 4 or minus 2. Chalo. Minus 2 is my selected dilution. So from that tube, I have to take 0.1 ml plus I have to take 0.1 ml of E. coli culture, and both the things I have to add in molten agar. Mix it well and pour it. Label the plate as a 20 minute. Okay. So that is the 20-minute time. Now again wait for more 5 minutes. If it is a 20, then now 25 minutes. After 25 minutes, again from that minus 2, take your 0.1 ml of lysate from that 2 and 0.1 ml of E. coli culture, add it into the molten agar and pour the plate. Add it as a 25. The same thing you have to do it up to 80 minutes, right? Then after completion of all this work, you have to incubate all the tubes at 37 degrees Celsius for 24 hours, and next day you have to observe the plaques, right? You have to observe the plaque on the surface of that plate. Okay, now the calculation part. So in the calculation part, one thing is very important. You have to focus here on few of the things. Like first, you have to focus on multiplicity ratio. So simply that is very easy to calculate the multiplicity ratio. So that is the number of phage in the adsorption tube divided by the number of bacteria. So simply number of phage 4 into 10 raised to 6 divided by 2 into 10 raised to 8. The number you got, that is called your multiplicity ratio, right? So if you want to find out the multiplicity ratio, simply divide number of phage divided by the number of bacteria in the absorption tube. Just calculate it, you will get the multiplicity ratio. Then what you have to do is you have to count the number of plaques on your plate. So in 20-minute plate, you have to find out the number of plaques. Suppose there are less than 30, okay, no problem. You cannot consider that plate because it's a less than 30. Or if it is a greater than 300, you cannot calculate it, right? So here in the beginning plate, it is less than 30. 25 minutes, it's less than 30. But after 30 minutes, 30-minute plates you got 45, later you got 57, then 102, 124 and 204, and 80 minutes it's a greater than 300, right? So we will consider this four, selected four, right? So this is the plaque forming unit, and we took 0.1 ml of lysate. That's why it is a 45 PFU per zero point 0.1 ml of this sample, right? So 1.1 ml of this lysate is having 45 plaques at the time of 30 minutes. It's a 0.1. Then it's very easy to calculate per ml. In 0.1 ml 45, so 1 ml how much? So you got 450 ml. Again, the dilution factor is very important. We selected 10 raised to minus 2. So 10 raised to minus 2 means what? 100 times, no? So multiply by with the 100. So you got 45,000. Right, so this is how you have to calculate the actual count. So when you multiply this PFU with the dilution factor, you will get the actual count of plaque forming unit, right? So in original sample, you have this much. Just convert it into the 10 raised to, so 4.5 into 10 raised to 1, 2, 3, 4, right? In that way, you have to write down the scientific way. You have to write down the numbers, right? So now you have to find out the relative titer. So you have to select one value which you considered first, that is the eclipse period, that is called the eclipse period. So this 45,000 is the eclipse period. So divide this by this, you will get 1. Now the next value for 57,000 divided by 45,000, you get 1.26. Then again 1,02,000 divided by 45,000, you will get 2.26. Again repeat the same thing up to 70 minutes. So maximum value you got, it's a burst size 4.53 is the burst size, that the maximum relative titer you obtain, that is called your burst size, right? So the calculation part is very easy. Simply you have to calculate the amount of PF in 1 ml, convert it into the 1 ml. After that, for actual count, you have to multiply with the dilution factor, and from that dilution factor, this is a final count. So from by using this final count, find out the relative titer. So relative titer is the eclipse period. The first time you got the PFU, that value, right? And it's a relative, means relative with this how much? So next value is 57,000. No, so 57,000 divided by the eclipse type, that is a 45. The same way for second, this divided by 45, this divided by 45. So you got this value. Maximum value is 4.53. So the 70, it's this time it is your burst size. This is how you have to find out the burst size. You have to find out the relative titer, and finally you have to conclude your data in this way. I hope you people are clear about this calculation part. If you have any doubt, you can contact me. So all the best for your examination. Thank you so much.